Good morning. Water is fascinating and demands our attention for many reasons. Water exists as liquid, gas, and solid, all with huge impacts on us and our world. Our own Mitch Erickson will review the science, biology, environment, and social use of water as a parable, like that word, parable? Intersection of science, environment, policy, recreation, safety, climate change, and social justice that affects all 8 billion of us. It's important to be informed about the fundamental properties of water in order to participate in societal discussions. Dr. Mitch Erickson is an environmental chemist by training. His career has focused on environmental contaminants, notably PCBs. He retired 5 years ago as an executive scientist from the U.S. Department of Homeland Security. Since then, Mitch has consulted on environmental chemistry and our technology future. Mitch is currently our Old Guard historian and has spoken to us several times on a variety of topics. So please, Mitch, welcome to the lecture.
Thank you, Richard, for the introduction, and thank you all for coming. I held off on introducing my guests. Online are my favorite brother and my other brother, and several other friends, my wife, and I want to say hi to Linda from calling in from Ecuador. It turns out that zooming from Ecuador is just as easy as zooming from a mile down the road. Okay, so let's see if we can fire this thing up. And I have a quiz question for you right off the top. I want you to name a beverage. We'll come to this at the end of the talk. A beverage that is less than half water. All right. I said somewhere that my favorite beverages are all mostly water, and I'm going to stick with that, and I'll see if you can come up with a beverage that's less than half water. All right, ready? Okay, I think that'll do it. All right, so we're going to cover water from the molecular to the global aspects. We all know about water in all kinds of different ways that we enjoy different things, skiing, canoeing, winter wonderland, etc. Okay, so what's water? Molecular weight of 18, melting point of 0, boiling point of 100. We all know that stuff. And every chemical out there has something called the materials safety data sheet. And here's the one for water. You can actually get an MSDS for water. And if you notice right there, it is a solvent, a cleaning agent. And we're going to talk about that. So when we say it's a great solvent, when we think of solvents, we usually think of alcohol, acetone, benzene, etc. But in fact, water is a great solvent. It dissolves things called polar compounds, salt, sugar, but it doesn't dissolve nonpolar things like chicken fat. And so in order for it to dissolve the greasy stuff, we modify it with a surfactant, and we use it in our cleaning, our cooking, personal hygiene, manufacturing. We'll get into all that stuff. And you know all this stuff. So let's go back to surfactants. Time for a little chemistry lesson here. There are molecules out there that have a fat-soluble tail and a water-soluble head that looks something like this. And when you put a whole bunch of them together, the tails all go to the center and heads all go out to the outside. And that's known as a micelle, M-I-C-E-L-L-E. And why is that important? Well, if you got micelles in water and you got this cartoon of a greasy dirt sitting on your skin, clothing, any surface, the micelle comes along and the water-soluble heads start attracting the dirt, and eventually the dirt gets sucked off of the surface, and the mice cells all rearrange and put the dirt in the center and heads to the outside, and voila, now your dirt is water soluble, and away it goes down the drain, into the sewer, etc. All right. Now, water is a natural resource. Unlike the one and dones that you see on the left, water, air, and all the elements recycle through our environment. We don't use up water. We don't use up air. We use it, we cycle it, but we do not use it up. Okay, so back to the science for a second. We all know it's H2O, and we all know that and the science guys have figured out really precisely what the dimensions of this molecule are. I'm not sure why you need to know that, but they know it. And if you remember Niels Bohr and the Bohr atom, there's another depiction. We know a lot about the science of it. And if you look at the way water molecules interact with each other, you see those little dotted lines between the red and the white there? Those are called hydrogen bonds. And they're important because that means that the molecules like to stick together, which is why a substance with a molecular weight of 18 can be a liquid at room temperature, whereas methane, which is molecular weight of 16, is a gas at room temperature. So these hydrogen bonds are important, and this is just a depiction of how they do it, how they kind of hold everything together. Now, we all know this: solid, liquid, and gas, ice, water, and steam, okay? A real quick aside, if you have a glass of ice water, you'll notice that the ice floats. And this is the only molecule out there where the solid phase floats. In all other things, when you condense from the liquid to the solid phase, the solid sinks. And this is really, really good, because we wouldn't be here if the solid phase sank, because all of the lakes and oceans would freeze over and the whole world would be much colder. And we also get a lot of neat things from floating ice, including pond hockey. Now I want to turn to the science for a second, and who better to explain science than Richard Feynman, Nobel Prize winner. And for those of us who read the book about Robert Oppenheimer, Feynman was the jokester that used to break into the safes at Los Alamos, and he also found a hole in the fence, so he went out of the by the guard shack and said goodbye, snuck in the fence. He kept doing that, and about the sixth time he left without coming back in, the guards finally woke up. And anyway, so in a solid, the molecules are like oranges in a crate. They're all packed together, and they're not jiggling enough to move around. When we warm it up, the jiggling gets more and more, and the water gets freer, and it becomes a liquid. You warm it up still more, and they bounce apart into individual molecules, and that's the gas stream. And also something from the same video, which is just basically a conversation with Richard Feynman from 30 years ago, is surface tension. We all know about surface tension. That's when the water beads up on a surface, and that's caused because the molecules at the edge like to have more partners. So they're always trying to burrow into the body of the water drop, and so they shrink the mass, and that forms the water droplet and the surface tension. And that's why, for instance, some of the very light insects can walk on water because of the surface tension. They go jiggling along on top of the water. Another aspect of water is aerosols. We all know about spray cans, and when you get these little fine, tiny droplets that don't fall to the ground immediately, they're called an aerosol. That's a technical term. We see aerosols in fog and in clouds. And we also had a big experience with aerosols 4 years ago when we had COVID come along, and people started arguing about whether 6 feet or 2 meters apart was was good enough, or whether they had to be farther apart. And that all has to do with how far does an aerosol go, and because even a teeny tiny water droplet that's too small to fall out of the air is still big enough to hold many, many, many virus particles within it. So, and when you sneeze or cough or whatever, and you exhale COVID virus, hopefully not, and that virus is not just a virus that's floating around in the air by itself, it's inside a water droplet. Okay, another little quick sciencey thing. We all know about concrete, and we all know we've all done this most of us have done this at some point or another. To make concrete, you take a bag of cement and you add water, and you make a paste or a slurry. And the setting of the concrete is not just drying. It's not just the water evaporating. It's actually a chemical bonding. And here's the process, the chemistry of it. The calcium silicate forms a hydrate, which is the purple, and the cartoon on the bottom at A, it hasn't started setting at all, and slowly the purple encroaches, and that's the hydration, which is why it takes a while for concrete to set up, okay? And also, if you're geeky, you'll notice 173.6 kilojoules off to the right there, and that's a bunch of heat given off. And if you've ever poured concrete, you know it does give off heat. And if you remember when they built the Hoover Dam, they had to build in pipelines and pump frozen or cold water through those pipelines to keep the temperature of the concrete within boundaries so it didn't crack and it set it up properly. So that's enough on concrete. I want to move over to another chemical, dihydrogen monoxide. Get it? 2 hydrogens, 1 oxygen. Okay. So the joke goes like this. Where do you find it? Well, it's a food additive. It's in beverages. It's in fruit juices. It's in shampoos, bathroom products. And furthermore, it's dangerous. If you accidentally inhale the liquid form of DHMO, it can kill you. If you're exposed to the solid form, ice, you get frostbite. And if you're exposed to the gaseous form, you can get steam burns. So this is really a bad chemical, right? And it causes acid rain. It leads to corrosion of metals. It's found in every tumor, and it was instrumental in causing Superstorm Sandy. So, in fact, we should probably ban dihydrogen monoxide. And this is actually a favorite thing that chemistry classes do at universities. They go to the county fair with a clipboard and a petition, and they explain all this stuff to people, and people say, oh, absolutely. Let me sign that petition to ban DHMO. And they have a grand old time. Chemists have a limited humor repertoire. So, all right. Now let's get back to water. On a global scale, US scale, almost all of our water is either irrigation or thermoelectric power. And I'll come back to that in a second. Domestic is only 8.5% of our water. And of that, then we go into what we do with that. And lo and behold, we put a lot of it right back out into our yard to let it soak into the ground and make our grass green. All sorts of other things. You can read the whole list there. But I want to go back to the thermoelectric power for a second. That's 40% of our usage across the country. And it comes from something like this. We mine coal. We burn it. And by the way, whenever you see that white stuff coming out of the smokestack, that's in fact condensed steam. Okay, that's not Now, there's also a lot of carbon dioxide coming out, but you can't see carbon dioxide in the visible range. So there's a lot of cooling that goes on, both in terms of like all of the fossil fired, but also the nuclear ones. And here's where Homer Simpson works here, right? And you go by those cooling towers, and there's this plume of steam that's coming out of them for sometimes you can see it for miles, and they're just pumping millions of gallons of water through, and they dump it right back into the river or the lake or the ocean or whatever. But still, that's part of the use. And again, remember, we're not using this; we're just cycling it through. The water that gets used, the 41%, 0.5%, doesn't disappear like it does when you burn coal. Okay, so the water cycle. Where does water come from? Where does it go? And what are the challenges? So first of all, the hydrological cycle is shown here, and you've got this nice blue lake, and water evaporates, or it can go through plants, and the plants give off a lot of water. And that all goes up into the air and gets to the colder parts of the atmosphere where it condenses. Then it rains. We all know about that from a couple of days ago, don't we? And then you get the precipitation, and either you get rivers running back into this lake, or it percolates down through the ground. Somehow it gets back in this lake, and the thing just goes around and around and around and around. That's the hydrological cycle. Obviously, there are subtleties to this, a lot of subtleties. One of my friends said, yeah, I spent 27 years in this. How are you going to do this in 1 hour? All right. And where is the water? Well, by far, most of the water is in the ocean. We know that. I mean, anybody who's ever taken a cruise, the oceans are big. 2.5% is fresh water, of which an awful lot of that is in glaciers, groundwater, and of the surface water, a lot of that's in permafrost and lakes. So the available water, even though we got this huge amount of water in the world, is really quite limited in terms of what we can use for what we want to use it for. So among the challenges with water is we need to keep it where we want it. We need to keep away from where we don't want it, and we'll talk about those. We need to use it, but we need to not abuse it. And it kind of comes down to being kind to your neighbors, and we'll talk about that a little bit. So let's just talk about some water uses in agriculture. This is California, where an awful high percentage of our food comes from. And you see animal feed is far and away the biggest use, followed by alfalfa, almonds, and you can read the list, and somewhere down at the bottom is oranges. But all of these things require water. And I want to just focus on almonds. And this is an almond orchard. And you see what they do to irrigate the almond trees is what they call flood irrigation. Basically, they open up a gate from someplace, and the water floods in there, and that water just sits on the surface of the ground. And of course, a lot of it evaporates, particularly on hot days. And but that's one. So I like almonds. Many of you like almonds, but it takes a lot of water to make almonds. And we also know, most of you have seen this from an airplane flying across the country at some point or another. No, this isn't crop circles. These are irrigation circles. But the basic irrigation looks something like that, where they're pumping the water out of an aquifer and spraying it on the crop. And somebody got a brilliant idea that when you do this, a heck of a lot of that water evaporates before it ever hits the ground. So what do we do about that? Well, we rejigger the irrigation devices so that they're spraying the water right down onto plant level, and you have less evaporation. Another interesting trick is to do it when it's cooler, like in the night. And so another way to save water with farming is a company called Arrow Farms. What they do is they raise lettuce and other salad greens in racks like this, and you can see the humans to give you a sense of the scale. And they also fine tune the LED lighting to what the plant's like and not what the sun would normally provide. And so they can increase the growth rate and decrease their electric bill. And there's what it looks like up close. This is hydroponic. There's no dirt. And lo and behold, they're right here in Newark. And they talked to us in August of 2018. And more recently, they've had some financial problems, but they seem to have come out of Chapter 11. And of course, there are many other companies like this that are doing indoor farming, not to mention Beyond Meat and the other companies that are making fake protein now. And so back to Aero Farms. This is an online order form, and you can see that the places right here in our area, Westfield, Madison, Berkeley Heights, and this is what the packages look like on the shelf. So you can go buy this stuff, okay? And the beauty is that they're not paying for nearly as much shipping as it would be if it was coming from California, and it's fresher. So it's an approach to saving water. And water is an interesting commodity because it costs a lot depending on what form you get it in. And Fiji water calculates out to over $10 a gallon. And I know that's bottled water is expensive, and Fiji's expensive by bottled water standards. But you know, $10 a gallon. Guinness is $64 a gallon, and a Grand Latte at Starbucks is $32 a gallon. So depending on how you adulterate your water, it can get very expensive. I want to do a quick history of water pollution. Forever, we've known about the fact that sewage is not good, so you want to get it away from your cave. And agricultural runoff's been around since forever. When the Industrial Revolution hit, we had to worry about mercury, lead, arsenic, the thermal pollution from power plants I mentioned, all kinds of organic waste that led to fish kills and so forth. And then as we got an environmental awakening in the around 1970, we started cleaning up our water treatment plants. We put in billions and billions and billions of dollars into wastewater treatment plants all over the country, all over the world. Ongoing challenges and future directions. We have to worry about what are called non-point sources, which are things you can't identify, a little outfall from a pipe, and climate change. And if you see that logo up in the upper left-hand corner, that means I used BARD to get this slide. And the BARD output was a whole lot longer, and I trimmed the words down. But basically, this is what BARD told me about the history of water pollution. So if you see that thing on there, several slides where they I used BARD. So artificial intelligence is here and living right in this room right now. Okay, public health problems. Diarrhea kills 2.2 million people every year, and mostly, sadly, it's for kids. And cholera is a waterborne disease. We have all heard the story of John Snow and the map and the pump handle in London in 1854. The pump handle story is basically people were getting killed by a single contaminated well water pump. So in order to stop people using the pump, they just took the handle off the pump. And it worked. And so that was the beginning of understanding that cholera came from contaminated water and not from miasma. Okay. Chemical contaminants and nitrates are a big deal in the agricultural world. Lead is something I'll come back and talk to you guys about lead sometime. Fascinating issue. But lead, and I'll come back and talk about lead in a few slides here. Schistosomiasis and giardia, a whole bunch of other parasites that get in the water. You may remember 20 years or so ago in Milwaukee, they killed a whole bunch of people with cryptosporidium in the water supply. And ongoing problems. We have about 2.2 billion people do not have adequate, safe drinking water. That's what, a quarter of the world. And even more people don't have wastewater treatment access. And so they're having to deal with contaminated wastewater. We'll talk about sustainable management of water resources, and hopefully our awareness is rising, including right here today. I don't know what happened there. That's supposed to say polio, and polio is almost gone. For those of us who lived through the 40s and 50s, polio was a scourge and terrible and awful. 6 cases worldwide in 2021. So as long as we keep moving on that one, I think that's a curable disease. All right, so let's go back to water. Water, water has bacteria and various pathogens floating around in it, and we want to kill those off. So what we do is we add chlorine, we get the water that we want. And chlorine just simply is a chemical that kills all of these red and blue guys down there in the corner. As an issue of water delivery, I love talking about the New York water system because it's just fascinating. The New York water system is gravity fed from up in the Catskills, and you see those red lines. Those are the aqueducts that they have that somehow or another go under the Hudson and around and about and wind up in the city. And it's just a miracle. And they have all these reservoirs upstate, and they're really proud of the reservoir. And this is from a 1955 report of the New York City Water Commission. And this is the reservoir in Central Park that you may not notice so much if you're on ground level, but it's right there. It takes up a good chunk of Central Park. And I want to point out that if you look downtown, it's awfully smoggy in 1955. And that's because we were burning a lot of coal for power plants. You see those guys over there on the East River, and every apartment building had its own coal-fired furnace and a garbage incinerator. And between the two of those, they pumped out a lot of crap. And we put up with that stuff. I mean, look at that air. We wouldn't put up with that today. And air is a side topic, but I just wanted to point that out. And you may have heard about the third water tunnel that took about 30 years to build. I don't know how many billions of dollars, and several of the sandhogs died, but this is the scale of the water tunnel. I mean, at some points, I think it's 60 feet in diameter. And we also have problems with maintenance of the infrastructure. The upper left, that's in Middlesex County somewhere, and there's Hoboken. And you see, you can have a flood just by breaking your own water mains. And I don't have a good map from around here, so we're going to use Santa Cruz. The yellow lines are all their sewer lines, and that's miles and miles and miles. And all those are in most cities, including around here, they're all 100 years old, and they all need to be refurbished. And so we see lots of things like this where the old cast iron or lead mains are all being replaced with plastic. And so maintenance. Okay, let's talk about Jersey. There's some of our water before it gets to us. And remember this slide, I want to talk about where the water comes that we use for all these different things. Where what's the source, what's our treatment, and how can you find out about all this stuff? Well, I'm going to tell you. Around here, Jersey American Water. Most of us pay a monthly bill to Jersey American Water. And they put out an annual report, and here's the 22 annual report. 54% comes from purchased water, which is a euphemism for saying that they got it from the Newark water system or somebody. And then it's about evenly split between surface water and groundwater. But we do have reservoirs, just like I showed you the ones for New York City up in the Catskills. Well, ours are up in northwest corner of New Jersey. And so Jersey American Water has a plant right here in Short Hills. In the lower left, that's the Short Hills Mall from the satellite. And you can see the Canoe Brook reservoirs at the top and the Canoe Brook Golf Course at the bottom. But where I got the circle, that's the water plant. And that's what they do all that stuff with. And they serve 2.8 million people. And their website has 1 million words on it about this, that, and the other thing. I'll just point one out, and that is that they have 9,420 miles of water pipeline. And on the left, on the right-hand side up there is all of the towns that Short Hills serves, but most of us live within that list of towns. And they have a report on the quality of the water, and they do a lot of testing on the water. And there's the lead, and you see a bunch of things, and all you care about is that it's within compliance. They are within the EPA numbers for lead and copper in this particular thing. And they're also looking at some of the unregulated new things. Everybody's hearing about PFAS, PFOS, fluorinated carbon compounds that we use to make Teflon, and we use in all kinds of different things. And there are no regulations on those things, but they're monitoring them. So they're on top of this stuff. And Jersey American Water is committed to getting all of the lead service lines out by the year 2031. Service lines are the water lines that go from the main out and under the street in front of your house into your house. And there's just a picture of a lead line. And that lead leaches out and contaminates our water after it's been treated at the Short Hills plant. And we'll talk about lead a bit more. So here's a little thing about what happens to the water after we've used it. And all of our houses have a little connection to the sewer, and the sewer comes through here, and all sorts of steps happen. And then either the semi-treated water gets pumped out, used in agricultural landscaping, or the fully treated can be dumped out into a lot of our towns. The case is into the Passaic River. What happens in the first part is that they get rid of the chunks, okay? And by chunks, I mean pieces of wood, toothbrushes, whatever comes along. And then they get rid of the smaller chunks, which are the sand and whatever, small things. And then they do something called aeration. And an aeration tank looks like this, and it's brown, and there's a lot of air pumping through it. Basically, this encourages the bacteria to chew up the organics in the sewage, and it's just an engineering way to really facilitate what nature does and what would happen if you pumped out the raw sewage into the Passaic River eventually. And then there's the chlorination again at the very back end. So, that's basically what happens. And if you want to go see one of these things in Berkeley Heights, there's what it looks like from the satellite. You can see at the top and the Passaic River running along over there. You can see Snyder Avenue on the right upper right-hand corner. But it's right there in Berkeley Heights. Similarly, New Providence, a little smaller, still right on the Passaic River. And this is at Oakwood Park. And for those of you who are are good members and come to our picnic is right over here. So, yeah, take a couple 100-yard walk and you could go look at our sewage treatment plant. Should you want to. It's actually a tour that every eighth grader should have. It's important. Now I'm going to move over to the drought. And this is from a year and a half ago. And I want you to see this map and see where all the drought is. And that's from a couple of days ago. And if I can toggle back and forth, there we go. Nope, anyway, the drought moves around, but we always got drought somewhere in our country and somewhere across the world. In the Midwest, they've had a terrible drought, and you can see these barges down below that are loaded with wheat, coal, corn, something, and they're just sitting there waiting for the river to get high enough that they can move on down towards New Orleans. So it's a big deal out in the Midwest, and you know, when the Mississippi River dries up, it's not good for a whole lot of economic and other reasons. We all know about the ongoing drought in the Colorado River basin. Colorado River drains parts of 7 states, and you can see it here. And right about there is where the Grand Canyon is, and you know, and it's been having a bad time for 10, 20 years now. And there's a standard picture of Hoover Dam. Many of you have been there, and in the old days before 9/11, you could drive across the dam, and you can't do that anymore because they built a bridge over here. And this is a hydroelectric dam. You can see the house down there with all of the turbines and the electrical distribution system there. And this pumps electricity out to a whole lot of the Southwest. Well, here's a more recent picture. Oops. And here, that white is the bathtub ring from where the water's drained down. And here's different pictures, and you can see how far down the water is and what happens, what comes up for when you drain the water and you find sunken boats and all kind of stuff. So Lake Mead's only 34% full, and that it's a good thing to be living in Jersey and not out in LA. And of course, that's just to go a little international. The Amazon's having a drought, and on the lower right, you can see how that little trickle of water coming through from what used to be a big river. And I was on vacation on the Rio Negro, which is a tributary, and it's 15 kilometers wide. It was 20 years ago. I have no idea how wide it is. But you know, the Amazon's having a problem, and there's drought everywhere. In the Northeast, we're in pretty good shape. This is a 52-week average, and basically everything's kind of either gotten a little drier or a little wetter, but no big deal. And there are times when this map looks a lot different, and we do have drought. And we also have problems with flooding. Up in the upper left-hand corner, that's the Somerset Patriots. One day when the game would have been canceled, and the upper right is the mall up in Wayne, and other flooding pictures. We know them all. These are all Jersey, and you know, when you get a flood, it's a bad day for everybody, and it does kind of clean out your basement, though, I got to say. And we do a lot of things to keep the water where we want it and not where we don't want it. And this is down along Seabright. Yep, you're right. And this, I think, is Hoboken, but and this is where you have a movable barrier to keep the water out. And we will not go into any detail, but this is all of the flood walls in Bound Brook and where they are and how they're designed and everything like that. But it's a big deal, and the Corps of Engineers has done a lot of work in a lot of places to help us be dry when we don't want to be dry. Of course, staying dry is also important at home. So you have a really good roof, and before you build a house, you waterproof the basement, and you put in a sump pump, and hopefully you go through life without having to put buckets in your living room to catch the drips from your leaky roof, or go bail out your basement because the water leaked in. I want to go to Sandy in 2012. That was 11 years ago, but there, the map of New York, and you can see the red areas are the ones that are most subjected to flooding. And I think everybody in the room's been through the Hoboken Path Terminal at some point. And the day that this picture was taken, you didn't want to be there. This is when the whole path station filled up with water. And then I got a picture of this guy standing there looking at his front lobby in Hoboken. Currently a Summit resident. Who is this? Nobody? Eli Manning. Even Eli got flooded out. And back to New York for a second. This is the High Line, 3 different views. You can see the High Line going through that aerial view, and a more close up and another more close up. And the High Line's a big deal because they converted this old railroad trestle into along Skinny Park, and it's really cool. But if some of the bad news stories come along about the way that the sea level might rise, we might see something like this. And in which case the High Line is not necessarily the High Line, but it's the dry line. And so these are, I mean, and the point of this is that, you can do something about sea level rise. And among the things you can, first of all, why do you do it? Well, remember, this is the blackout from Sandy when the lower third of Manhattan was dark because of the 14th Street substation got flooded over on the East River. So what do you do about it? Well, you could put something around $15 billion into a big wall around New Orleans, and we are doing that or have done it. And the other thing you can do is you can raise the street level. And that's been done in Chicago and Galveston and Atlanta. And this is a postcard from Galveston. And they put 3,000 jacks under this brick church and went, and over the period of months, they raised that church. I think it was 4 feet that they raised Galveston, but you can raise a city. Now, doing a church in Galveston is a whole lot different than doing Manhattan or Hoboken, but I'm just pointing out the possibilities. So let's go back to the bigger more global issues. Here's what a century difference in pictures look like in Glacier National Park, and they've conveniently placed a person in about the same position as before. And Glacier is probably going to have to get renamed to what, non-Glacier National Park? I don't know. Another way to look at it is this is looking down on our Earth, and Alaska's over here, Russia's all over here, Greenland is the gray thing here. And you see, in 30 years ago, we had about that much ice on the 13th of September. And in 2020, we had only about half as much ice in the polar ice cap. And 13th of December is when it should be at about its smallest. Anyway, so what does that mean? Well, another view of that is, the ice is gone, and so we can start thinking about a Northwest Passage with shipping, and whether that's a good way to transport materials. But this guy is not a happy guy. So, let's go to policy. Like with the Colorado River, we got these old policies. The river pact for Colorado is somewhere over a century old, and they need updating to reflect our current priorities. We are sucking down aquifers and groundwater all over the world, and a tragedy of the commons, right? You can you can suck down the groundwater, but it's everybody's groundwater, so it's nobody's groundwater, so what the heck? and the lead pipes again. We can anticipate water wars. And the easy bottom line is to simply do fair pricing on water. If you fair price it, then people will start using it appropriately, and we will have less of the gross abuses we have now. Going back to 2019, lead crisis in New York leads to distribution of bottled water after filters fail to safeguard homes with old pipes. What's the problem? Well, you know, the people got pissed off that they were drinking poison water. And so we brought in bottles of water like that. And fast forward to this year, and they're, the White House is going to protect all the communities from lead pipes and lead paint. Like I said, there's a whole lead story I'll tell you some of the time. So there's a lead pipe and a new plastic pipe, replacement pipe. And here's a guy, this is actually in Newark, and this guy is replacing lead pipes. And see, this is not trivial. I mean, you got to go dig them out. And this project's going to cost somewhere between 20 and $30 billion over the course of a decade. But, you know, it's important. And locally, in August, New Jersey American Water and the Community Summit were advertising that they're on this project. Okay, I mentioned water wars, and again, this is Bard telling me the story. In the U.S., we got dry wells, we got agriculture and industry sucking towns dry and leaving the residents with not even a trickle coming out of their kitchen sink tap. So if you think that millions and millions and billions of people across the world are going to sit by idly while they and their kids can't get fresh water, you think again. You know, people get really owly when they don't have water. And this is a global problem. These are all different rivers and water areas with, you know, tens of millions of people living next to them. And one of them is the Mekong River there that goes down through several countries, part of the river. I mean, tens of millions of people need this river for their water. And as a business risk, this comes from a book I'll tell you about in a second. The true cost of water is 3 to 5 times what's built into the planning for Coca-Cola and everybody. And Barclays thinks, okay, so $200 billion of scarcity risk. So my message to you, particularly you guys in FIG on Friday, buy water. We need clean, reliable water. We just talked about the $200 billion. So desalination plants, de-risking floods, these are all things. And to prime the pump, the Inflation Reduction Act is $1.2 trillion. That's going to pump a lot of money into different water aspects, and it'll catalyze even more private sector money. And as we heard from Jeff Gitterman here 2 or 3 weeks ago, use the ESG to inform decisions, and that's his book, which is about 80 pages long and easily downloadable from the internet. And so, you know, go to the stock market, buy it, and you'll be a rich man. Now, for another day, I hear you, John. For another day, how did we get water here on this planet in the first place? What did it look like when we had a mile of ice above our heads here in New Jersey? Glad I talked about more on water and disasters, water policy. I'm not going to subject you guys to all this stuff in anytime in the near future, but sometime along the line, I'll subject you. So I'm finally done. I apologize for running over, but I started even later. So now I guess it's time for question and answer. Stay right here. Again, I apologize. I forgot. I apologize for sitting down, but I got a bad back. And I mentioned the beverages that are less than half water. That would be any alcohol that's over 100 proof. So Wild Turkey, Everclear, and you can't add ice. You can only drink it straight. Then it's less than half water. But other than that, every beverage you've ever drank is over half water. And make it short.
Okay, so what's the timetable of the water crisis versus our ability to catch up and contain it?
Well, we've always had problems with water. We've always had issues. And so right now, we have, it depends on what problem you're solving. If you're solving the billions of people that don't have adequate water, that's been ongoing for forever. But in terms of, let's drill down to Jersey. We're in good shape. We got to get those lead pipes out of the system. We got to keep cleaning the water up and so forth. But as long as there isn't a major upheaval in our climate, we're okay. With the following caveat: we have lots and lots of aqueducts and rivers and so forth that are out there that are, a lot of that infrastructure is a century old. So we're going to have some failures, and how we deal with that, I don't know. Nationally, things like the Colorado River and the Mississippi River, we just have to adjust to the climate realities and the fact that it's not just climate. I mean, we got how many more people are in California now than were there when they made that water pact 100 years ago. I mean, it's just a different world. Okay. Sorry, big answer.
Next question is online from John Macheda.
Hey, John.
We'll have to look at the.
Thanks. Great talk. Mitch, with the glaciers are a big source of fresh water, and they are basically not necessarily disappearing, but they're shrinking. What kind of economic impact will that have in the future when the fresh water will become much more expensive?
I'm not sure, but obviously, the glacier melt, particularly in the Himalayas, with all of that glacier melt that feeds the Indus River and a couple other major rivers. That's going to be devastating for India. And similarly, the solution to the Colorado River is to have several years of a really big snowpack in Colorado. And the skiers will love it, and the people downstream will love it when it melts off in the sun. But, it's one of many problems associated, and there are a lot of really simple solutions. One is to desalinate water if we can only have free energy, right? Okay.
Okay, great talk, Mitch. And of course, there are lots of questions. I was going to start with an answer, but then you gave it, which is 101 proof vodka. I guess the Russians have a lot of that. A quick comment about the freshwater in glaciers. I'd heard that years ago, all of the lakes in the Adirondacks were devoid of fish because of acidity that came down in the form of acid rain. So clearly, a lot of air pollution causes the water falling out of the sky to be not pure. And I'm wondering whether the top layers of the glaciers are therefore not really pure water anymore. But my actual question is this about chlorination. And, you know, everybody's always talking about whether chlorine in water is a good thing or not, let alone fluorine. And my water at home has a pretty strong odor of chlorine. So that's really why I drink bottled water. I guess the chlorine is safe enough. But is the chlorine in water that they use, is it gaseous so that it will evaporate if I leave the water in a container, in an open container? Or is it in a solid compound like what they put in swimming pools? So it's going to stay there no matter what.
I'm no expert on this, but I believe that the chemical that's added at the Short Hills water treatment plant is something called sodium hypochlorite, and it comes in a solution, which they then, you know, I mean, the cartoon I showed you was a gas tank of chlorine. Well, it's actually slightly different than that, but yeah, there is a concern about chlorine and chlorination in water. And one of the tricks to do is to use ozone instead, and that's some water treatment plants are doing that. Alejo, hi. Hold on just, Al, we're going to get you unmuted here.
A very important talk. How important and a problem is PFASs in the water supply, and what should we do about it?
PFAS, which is an acronym for the fluorinated organics, it's first of all, it's what's called a forever chemical. That means they do not degrade, and it also, because they don't degrade, it means they don't have any acute toxicity. You know, drinking a glass of water contaminated with PFAS is not going to kill you. Okay, it's but is it good for you? The jury's still out there, still investigating the toxicological. Meanwhile, people are worried about it. I was just down in Wilmington, where you are, Al, and the PFAS in the Cape Fear River, and our friends have quintuple filtration between what's going on in the water treatment plant there and what they do at home. But you know, you can filter this stuff out, and it's the ongoing, it's the emerging contaminant of concern right now. Anyway, and by the way, if anybody wants really pure water, go buy a gallon of distilled water at the grocery store and drink it. It won't kill you, but it sure doesn't taste very good. So, what else?
This is going to have to be the last question, I'm sorry to say. From Rich Jagger.
Yeah, Mitch, I think you mentioned that the price of water should be 3 to 5 times what it is. How is the price of water set? Who sets it? And how would we go about getting the right price there in the marketplace? And would that be a good thing, or would that hurt a lot of people?
Well, I actually don't know the details of like who sets the prices of our water that we get here and out of Jersey American Water. I'm pretty sure that they have a calculation that includes their profit. But I don't know how that exactly works. I do know that like the cost of water from the out in Colorado, those are highly variable depending upon rates that were set 100 years ago. And so farmers pay far less per gallon than a residential customer. And those are just the kinds of things that how you do that, it's going to take some national pressure. It's going to take some renegotiation of some of these water packs. And, you know, it's no simple thing. And the impact of that is pretty simple. We're going to pay more for some things. Like, you know, the 3 to 5 times was on industrial water. So if I don't know what the cost of water is to Coca-Cola bottlers, but you're going to pay more for Coca-Cola products, obviously. And who will pay less? I don't know where all the economics are, but anyway, enough of that. And Tom and Miguel and everybody else who had questions, find me offline, we'll talk.
Thank you, Mitch. Very fascinating topic, one I was looking forward to for some time. As you know, we have two ways to thank our speakers.
Really?
Yeah, let me tell you about it.
Really?
Yeah,
What's that red thing on the?
yeah, that's an orchid.
Oh, really?
Yeah, as you know, back in 1930, when the Old Guard was created, we were the capital of the orchid world. And so that was adopted
Thank you.
by the Old Guard. Thank you very much. And now the Old Guard salute.